Hi everyone, I'm Abhishek, a customer engineer for machine learning at Google Cloud, and welcome back to the Technical Guide for Startups, where we are creating a series of videos for technical enablement to start, build, and grow their businesses successfully and sustainably on Google Cloud. In our previous episode, we shared with you how to visualize your data with Data Studio and Looker. Today, we are moving on to our eighth stop, which is machine learning on Google Cloud with pre-built APIs and AutoML. In today's video, we will be covering how to select between the various Google Cloud products for your ML use case, what are the different ML APIs that Google Cloud offers and how you can use them, workflow for creating a production custom model, and finally, how to use AutoML to leverage on Google Cloud's machine learning expertise. Selecting the right machine learning product. This decision tree gives you a quick overview of which product to use. Let's go through this in a bit more detail. If you do not have your own training data and pre-built models fit your needs, ready-to-use ML APIs are the way to go. If you do have your own training data, but you do not plan on building the model or writing the code from scratch, AutoML is the right choice for you. If you do have the training data and you do plan on writing your own code in SQL format, BigQuery Machine Learning is your buddy. And if you do have your own data and you are planning on building your own model in a non-SQL format, typically with Python and using frameworks like TensorFlow, custom model tooling of Vertex AI is the perfect choice. Machine learning APIs are extremely powerful, pre-packaged solutions that help you get started on your ML journey right away. You can make use of Google's world-class, state-of-the-art models to accomplish the most common ML tasks. If you need more customization for your task with custom predictions and custom datasets, you can make use of AutoML. You can start building your own high-quality custom models by using advanced techniques like learning to learn and transfer learning from Google. Cloud AutoML can make AI experts even more productive and advance new fields in AI and help less skilled engineers build powerful AI systems they only previously dreamed of. Finally, for data scientists and ML engineers, Vertex AI allows you to easily train and compare models using AutoML or custom code training, and all your models are stored in one central model repository. These models can now be deployed to the same endpoints on Vertex AI. It also comes with a whole host of other features that we will be exploring in the next video. Using pre-trained models with APIs. Let's start off with the scenario where you do not have your own training data. In order to leverage ML for your use case, we recommend using Google Cloud's APIs for pre-trained models. Google Cloud currently offers 6 major ML APIs as part of our Cloud AI offerings: Cloud Vision, Cloud Video Intelligence, Cloud Natural Language, Cloud Translation, Cloud Text-to-Speech, and Cloud Speech-to-Text. We will now explore a couple of these APIs. Natural Language API. Let's explore a simple demo of the Natural Language API on its homepage. Fun fact, you can actually explore all the ML APIs free of charge on their respective homepages. I have added a standard description of Google in the text box as input to the API. From that, you can see the output as shown in the figure. There are 4 main tasks that the Natural Language API can do: entity analysis, sentiment analysis, syntax analysis, and content category classification. Natural Language API has a few interesting features. It can perform sentiment analysis. It essentially can decompose a sentence and identify the different parts of speech in it, like a noun, verb, etc. It can also do the task of sentiment analysis. For every sentence, Natural Language API can provide a sentiment rating on a positive to negative spectrum. It can also perform entity-level sentiment analysis. It can perform content classification into predefined topics and subject matters. Finally, it is able to do entity analysis which basically identifies and categorizes entities into 13 different entity types. You can use all the ML APIs the same way, through an API call or through the Google Cloud SDK. A sample request to the natural language API to classify text looks something like this. Vision API. With Vision API, you can use REST and RPC APIs to automatically classify content using predefined labels, detect objects and retrieve object coordinates, identify products from your catalog, detect brands and product logos, detect faces and emotions, detect popular places and landmarks, find similar images on the web, moderate explicit content, identify image properties like dominant colors, get crop hints, and finally detect and extract printed and handwritten text. Luna Park is an amusement park in Sydney. If we send this image as input to the Vision API, we can test out the various features. The first one being label classification. Some of the probable labels it outputs are landmark, architecture, and amusement park, but with different levels of confidence. Similar to that, it is also able to detect emotions based on the facial landmarks. You can get the confidence levels of different emotions as well as part of the API response. Vision API also has the capabilities to do OCR on the input image. As you can see from the Luna Park image, it is able to clearly recognize the signboard. Another cool feature about Vision API is that it can perform landmark detection. This detects popular, natural, and human-made structures within an image. Video Intelligence API. The Video Intelligence API is similar, except it analyzes videos. It can do things like track objects, transcribe audio, detect explicit content, and more. You can still process large video archives stored in Google Cloud Storage as a batch process. Or you can use the Streaming API to annotate videos in real time to take immediate action. Capabilities for live streaming support HLS, RTSP, and RTMP protocols. Let's now explore the other APIs in the form of a demo. I will be showing you a demo of a web app which chains together three APIs: Speech-to-Text API, Translate API, and Text-to-Speech API. This will show you how you can get near real-time translation of a speech from one language to another. As you can see, I have this very simple web app with a couple of different options. I can choose my input language from a list of different languages we support. In my case, it will be English. And my target language, again from a list of different languages, and in my case, it will be French. I can also choose the model that will be used to perform the speech synthesis. We have two different options here, a standard and a wavenet. A standard voice is just parametric text-to-speech, which generates audio by passing outputs through signal processing algorithms called vocoders. There is also a wavenet voice, which is a premium voice generated by the wavenet model, which we use to produce speech for Google Assistant, Search, and other products. This is more natural sounding than other text-to-speech systems. And finally, you can select the variation in the voice you would like. Let me select option B. Now, when I press click to start and speak something, the app will translate my words from English to French. Let me show you what that looks like. Hi, my name is Abhishek.
Salut, je m'appelle Abhishek.
Welcome to the Technical Guide for Startups.
Bienvenue dans le guide technique des startups.
As you can see, by chaining multiple APIs together, we are able to perform a speech-to-speech translation instantly. This can be used not just to impress your friends, but also has a lot of real-world applications in various industries like e-commerce, retail, banking, legal, customer service, and so on. Hope you enjoyed that demo. Let us now talk a bit about when you would potentially need to use ML for a custom task that you may be having. What about custom tasks? How can Google Cloud help you solve them? Now I know this is a very simple use case, but imagine there is a scenario where you would need to classify whether an image is a cat or not. This can be accomplished by calling the Cloud Vision API and checking the confidence scores for the label of cat. But now, if you know that your input image is a cat, you now want to know what breed of cat it is. Then how can this be accomplished? A pre-built API would not be helpful in accomplishing your task here. We would, in fact, need a custom cat breed prediction model. Let us now see how you can build a custom cat prediction model in general. Step 1 is to identify the problem. We define the problem as to identify the different breeds of cat from an input image. Step 2 is to gather the pre-processing data needed to train a custom model. In this step, we either find a dataset or scrape the internet to get different sets of breeds and create a dataset with these labeled breeds. In step 3, we split the entire dataset into two parts, one for training the model and one for testing it. We do not expose the testing dataset to the model during training. This removes any bias in the model prediction and ensures that our model generalizes well. Step 4, we then need to use a machine learning framework like TensorFlow, import various libraries and build the model structure. This process gets more and more complicated as we go on. Step 5, we finally train the model and evaluate the model against the unseen data in the testing dataset. Finally, if we want to productionize the model and expose it to the end users, we need to save the model artifacts and deploy it either as an endpoint hosted on Google Cloud or get it running locally to serve the predictions on device. Step 7 is that we can finally serve the predictions by hitting the predict endpoint. This entire process gets super complicated at the end. So, is there a way to simplify this entire process? Absolutely. That is where we have AutoML. AutoML provides a UI for gathering training data and evaluating models. Here's how it works. Upload your training data. Depending on which AutoML variant you're using, it could be images, text, or translated sentence pairs. Next, click the Train button in AutoML UI to train your model. It is as simple as that. Once your model is done training, it will be automatically available for predictions on Google Cloud and it scales automatically. Finally, you can generate predictions. You can try it out in the UI or build an app that queries your trained model with the API. So how does the entire process to build a custom cat breed prediction model look like now? You can see that once you gather the data, your job is pretty much done. AutoML handles the splitting of the data, training the model, evaluating it, and deploying it into production. All that is left to do is to make the predictions and harness the power of ML in your application. We saw a use case for AutoML Vision. Let's see what else you can do with AutoML. In particular, AutoML Natural Language. You can create a model that is able to generate custom labels. For example, here we are looking to classify the description of a movie into different movie genres. To achieve this, you can download a public dataset from Kaggle, like the Movie Lens dataset, and use that to train the AutoML natural language model. Another interesting use case you can build using this is a custom sentiment analysis model. For example, let's assume you are an airline company and you would like to classify how satisfied or dissatisfied your customers are with you. You can build a custom sentiment analysis model using AutoML. Another use case could be in terms of entity extraction. Our pre-trained entities may be a bit generic for your use case. For example, cappuccino here is recognized as a consumer good. You can then train an AutoML model to perform custom entity extraction. In this case, it is able to recognize cappuccino as a beverage. AutoML tables. According to McKinsey Global Institute, data in its basic form, structured data, is likely to drive most of AI's impact, with time series being a close second. In order to help you overcome these challenges, we decided to build AutoML tables, a tool for enabling your entire team, data scientists, analysts, and developers. It helps to automatically build and deploy state-of-the-art machine learning models on structured data. Based on the benchmarks we've done, the results speak for themselves. There are a number of vendors in this space, and we chose to benchmark against a subset of them with similar functionality. Benchmark on Kaggle competitions, which I love as a benchmark because they involve real data from a real company that is putting tens to thousands of dollars of prize money on the line to get a good solution and willing to wait months to get a good result, and thousands of serious data scientists around the world compete. Tables are usually in the top 25, which is usually better than existing vendors we tested. So overall, we do quite well. Let's deep dive on one of the datasets where AutoML tables performs well, the Mercari Price Suggestion Challenge. Mercari is Japan's biggest community-powered shopping app and marketplace. And they created this challenge for predicting the price of a product offered on their marketplace, so that they could give price predictions to their sellers. 3 months, $100,000 prize, 2,000 data scientists competed, and there were 99 entries for the winner. The entire dataset consisted of 1.5 million rows of rich data, which had plenty of noise. Now, what you see here is a curve where we laid out the performance of each participating team in terms of the final error rate they achieved. On the x-axis is the team's rank on the final leaderboard, where going more to the right means that they did better. And on the y-axis is the error, where higher means that they did worse. As expected, you see a curve down to the right, but this curve isn't even. A steep drop where every subsequent team does significantly better than the previous one, followed by a long plateau where each team does about the same, almost as if the signal from the data has already been squeezed out of. This is how tables performs after different hours of training. There are some caveats to this. The search process is random. We did do some limited data cleaning, and of course, other datasets could have different results. But still, for a million plus row dataset with significant complexity, 1 hour gets you to the plateau. And oh, by the way, compared to the $100,000 price for this challenge, 1 hour of training is just 19%. And click one more time and the model is ready for deployment. This brings me to my final point. AutoML tables will save you money. Not only does it increase your team's efficiency, but there is no large annual licensing fee. You just pay for what you use. This is a small margin over what the cost of the underlying compute and memory infrastructure used would be. So for example, training costs $19 an hour, like I said earlier, and this represents the use of 92 4 CPU machines under the hood. And prediction and model deployments are even cheaper. Let's talk about JobCam and their ML journey on Google Cloud. JobCam is a SaaS which uses video technology to help recruiters to reduce unconscious biases during hiring process using AI. They conceal the candidate's identity by blurring their images and changing their voices in video interviews or video resume. With this, they help the decision maker to evaluate candidates just for their competency, abilities, and experiences instead of their gender, race, ethnicity, religion, etc. They were able to reduce processing times for automatic speech recognition using speech-to-text API by 93% from 5 minutes to 20 seconds. They also use cloud storage to reduce the video serving latency to their end users, thereby providing them a better experience on the platform. Today, JobCam is a platform connecting various companies with more than 50,000 job candidates in Brazil alone. The process shakeup led to a 130% increase in turnover in the social distancing phase alone. Coming up in the next session, We will be exploring more on the machine learning options within Google Cloud, an overview of Vertex AI, AutoML capabilities with Vertex AI, custom model building with Vertex AI, and finally a demo and a customer case study. Hope this video has been informative to you and your business on how you can leverage the power of Google Cloud's machine learning APIs to build and grow rapidly.